Good morning, morning class, and good afternoon, afternoon class. As you may be able to hear, I am at the beach this beautiful day, waves crashing, and I'm here because I think there are people at this beach who don't know how this beach got here, or where the sand came from, or how any of that works. So I'm here to ruin their day and tell them. And not to leave you out, I don't want you to feel left out. I'm here to ruin your day too, because even from afar, today I want to teach you how to represent a number and its opposite. Before I get started, if you would, please get yourself kind of into lesson mode. Put everything down, empty your hands, get your concentration ready, finish dealing with your hair, your clothes, your stuff, your food, all that, so that you can concentrate as I do. So you've already learned some places where we see negative numbers and what they mean. We watched a video about yourself, and we talked about kind of the meaning of some negative numbers, like when you owed your friend Raul $80. You kind of had negative $80 at that point because you owed $8 to him. We talked about when you overtweeted, when you were being chased by a zombie, you had negative 27 characters left in your tweet. We talked about that time you fell into a hole and you were negative 18 feet above ground, so 18 feet underground. We talked about it being really cold. And on your dolphin ride, when you were 40 feet underwater, we talked about you having an altitude of negative 40 feet. And all that should be memorable to you because that was all you. Happened to you. Oh, didn't rewrite this, but today I want to teach you, now that we've got that kind of out of mind, I want to teach you how to represent a number and its opposite today. All related, pretty simple. Oh, there it is. I did write it after all. I wouldn't have made such a mistake. All right. So let's start with this word opposites. Word you have probably known since preschool, but of course, every word has its own meaning in math, and today we need to talk about what the word opposite means in math. So in math, we call positive and negative numbers that have the same value opposites. Negative 6 is the opposite of 6. 12 is the opposite of negative 12. Negative 6 3/10 is the opposite of 6 3/10. And 1/3 is the opposite of negative 1/3. We're going to say these are opposites. They have the same value, we would say. They both have a value of 6, but one is positive. Remember, we don't always write the positive sign. We do always write the negative sign. So we say the positive and the negative version of the same number are opposite. Hold on, let me turn this YouTube wave sound off. It's getting annoying. Okay. So that's what opposite means in math. Call these numbers opposites. The reason we call those opposites is that they're in the same distance from zero on a number line, but in opposite directions. Let me show you what that means. So if I were to draw a number line here, I'm going to put 0 in the middle. You know, I know for a long time when you only dealt with positive numbers, you always put 0 at the beginning. But now since we have positive and negative numbers, I'm going to put 0 in the middle. If I draw my notches accurately, 1, 2, 3, 4, 5, 6, there's positive 6. 1, 2, 3, 4, 5, 6. In the opposite direction, there's negative 6. If I put those both on the number line, they're the same distance from 0, as I said, to get to 6 and to get to negative 6. You go the same distance, just in the opposite direction. That's why we would say negative 6 and 6 are opposite numbers. Same, 12 is the opposite of negative 12. Sometimes I don't draw all my ticks on there. I'm just going to kind of say, okay, 12 is going to be way over here. And the same distance the other way, I would get to negative 12. It's the same distance, but in the opposite direction. So 12 and negative 12 are opposites. Decimal is just fine. They can be too. If I kind of go back up to my 6 and my negative 6, I'll just do it on that one actually. Change colors. Blue, 6 3/10, negative 6 3/10. If this is 7 right there, 6 3/10 would be between 6 and 7, so it'd be about right there, a little closer to 6 than 7, so it'd be about that far. Same thing, to get to negative 6 3/10, I would just go to negative 6, and I would pass it by a little, but not get to negative 7. It's still the same distance from 0 in the opposite direction. So we call them opposites. And number lines are a big way we represent numbers and their opposites. Last but not least, if I want to do a fraction, also no problem. I would probably put 1 way over here, -1 way over here. If I want to do thirds, I would partition into thirds. That's 1/3, 2/3, 3/3 is 1, -1/3, -2/3, -3/3 is 1, and we're talking about this number right here and this number right here, 1/3, -1/3. They're the same distance from 0 in opposite directions, so we call them opposites. Number lines are one way you often represent positive and negative numbers and their opposites. Another one we do is these is positive and negative symbols, as I'm going to call them, positive and negative symbols. Opposite numbers have the same number of symbols, but the opposite symbol. So sometimes you'll see me represent -6 like this with 6 negative signs, like that. And you'll see me represent 6 with 6 positive signs. As you can see, they have the same number of symbols, 6 here, but opposite in their direction, opposite in their sign, -6, +6. Same with 12. You might see me represent 12 with 12 positive signs. 8, 9, 10, 11, 12. And if I do, I would do 12 negative signs for -12. Same number of symbols, opposite symbol. When it comes to decimals, I don't really do this. Writing 6 wholes and then 3, I don't know how to write 3/10 of a symbol. So I often wouldn't use this particular way to represent either of those. I'm sure there's a way to do it, but it's probably one that makes it more confusing than not. But if I could, I would draw 6 3/10 positive symbols and -6 3/10 negative symbols. If it were, there would be the same number, they would just be opposite signs. Last way you'll often see teachers represent positive and negative numbers or numbers in their opposite is with these counters that are red on one side and yellow on one side. You can kind of flip them over and show either number. If you do, you would say usually the red side is the negative. So when you saw 5 red counters, that would be -5. And usually the yellow side is the positive. And so you would say that's 5 or that's +5. It's okay to write the positive symbol, you just don't need to. And as you can tell, same number of counters, they're just opposite colors. That makes the numbers opposite. Hopefully a pretty simple concept. There's one little thing that's a little tricky and worth remembering before we go on. The opposite of 0 is, if I think about it, remember opposites, if I go back to this number line strategy, they're the same distance from 0 in opposite directions, right? So when we did 6, we went 6 that way. When we did -6, we went -6 that way. But 0, I don't have to go anywhere to get there. Like there's no distance to go, it's just right here. So weird thing about 0, the opposite of 0 is still 0. It's its own opposite because there's nowhere to go. It's kind of like whoop and whoop. Like we don't go anywhere to travel. So, and we don't say -0 or opposite of 0. We just don't write that number. So 0 is its own opposite is maybe one little tricky piece of trivia to do this. All right. I'm going to go on to some other things here. So let's do a couple together, so to speak. Here I want you to kind of participate with me, think along with me. So first things first, in math we call positive and negative numbers that have the same value. Positive and negative but same value, we call those, excellent, we call those opposites. We do that because they're opposite directions usually. I'm going to put that. So -3 is the opposite of a 3. 18 is the opposite of -18. -7 and 1/10 is the opposite of +7 and 1/10. And 2/5 is the opposite of -2/5. 0, slightly tricky one. 0 is the opposite of itself. So still 0. If you would, pause the video here. Your WeDo notes sheet has these blanks to fill in on there. Go ahead and pause now, do that, and unpause when you're ready to continue. All right, next thing to know is how we do this on a number line. So if you'll think with me here, kind of pretend to participate since I'm not actually with you. So I like to make my number lines. I like to put 0 in the middle now because we have positive numbers on one side, negative on the other. We used to put it at the beginning when we only dealt with positive numbers. And the reason we call these opposites, like 3 and -3, there would be 3, there would be -3. And what is important about that and where that term comes from is they're the same distance from 0 in opposite directions. Same distance from 0, opposite directions. 3 is 3 to the left of 0, -3 is 3 to the right. I got those backwards. -3 is 3 to the left of 0, 3 is 3 to the right of 0. If the number gets bigger and I actually put it on the number line, I often just skip straight to it. Kind of cheap, but a lot of time I'll just say, okay, 18 is pretty far from 0, and I'll just kind of do that. Its opposite is the same distance from 0 the other way. I'll probably just put it, and I won't try to put all the numbers in between. You're welcome to put the 17 partitions in between if you want. I just don't want to. So put them there. You could also probably just not go by ones. You could go like 3, 6, 9, 12, 15 if you want. But that's not necessary either, as long as you know what you're doing. When it comes to decimals and fractions, I don't usually use a number line. Oh, no, I do. I'm sorry. I don't use the counters. I can use a number line. 7 and 1/10. What I would do to get to 7 and 1/10 from 0, I would start at 0. I would go to 7. I would go a little past 7, but not all the way to 8. 7 and 1/10 is probably right there. Much closer to 7 than 8. But between them. So the same thing the other way. If -7 is here and -8 is here, I go a little past 7, but not all the way to -8. Same distance, opposite direction. I'm out of space for this one. I'll do it up top. 2/5. The way I would do that, and it's opposite. I usually put 1 way off to the side when I do a fraction. That way I have the most space to partition my stuff. So I would do, this is in fifths. So I'm going to partition into fifths. That's 1/5, 2/5, 3/5, 4/5, 5/5 is 1. 1/5, 2/5, 3/5, 4/5, -5/5 is -1. So 2/5 is here, that far. -2/5 is here. It's 1/2 in the opposite direction. So same number, opposite direction, same distance from 0. That's how it works. Go ahead and pause now. There's a space for this on your WeDo as well. Yeah. We also use symbols a lot of the time to do these. There's a column for the symbols on your sheet. So if I'm going to write -3 and +3, -3 I would write with 3 negative symbols. +3 I would write with 3 positive symbols. That's as simple as that gets. 18 and -18, same thing. I would write 18 as 18 positive symbols. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18. Positive 18, 18 positive ones, so to speak. -18, 1, 2, 3, 4. Oh, they're all going together. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18. There's 18 negative ones. I don't do this strategy with decimals or fractions. It's too hard to write 2/5 of a plus sign. I'm sure there's a clever way we could do it, but I'm not going to bother to right now. All right, and the last thing you might see is these colored counters. Usually they flip, so yellow's on one side and red's on one side. So usually -3 you would see written with 3 red dots, and +3 you would see written with 3 yellow dots. If you use those counters. 18, same thing. I'm going to let you squeeze 18 yellow dots and 18 red dots onto your chart. And when you do, you are to the end of this. So take a moment now, get that notes page into your notebook. Oh, same thing here. If I didn't say so, I wouldn't use this strategy on those two. Too hard to get 1/10 of one of those counters or 2/5 of one of those counters. Okay, that is it. UDO Together is up next on the next slide of your video. So once you've got this taped or glued into your notebook, you are good to go, and I will see you next time.